I'm Joshua Bardwell, and you're going to learn something today about soldering. I've got an interview today with Randy Rubenstein from SRA Solder, and we're going to talk about all of the things that you're doing wrong and how you could get better at soldering. And we're going to give away an $80 soldering station. You interested? Stay tuned. I'm really excited to bring you this interview today. I really enjoy soldering. I do, and I think I'm good at it, reasonably good at it. And some of you guys think there are things I'm doing wrong. Like some of you think I set my iron way too hot. So I was really excited to get the chance to sit down with Randy Rubenstein from SRA Soldering, who is a soldering professional, and find out who's right, me or you. And I asked him a whole bunch of questions that many of you guys out there who never got any formal soldering education need to hear the answer to. Please listen to this whole interview and soak up some of the information that I tried to get into it. I think a lot of you are going to learn a lot, and it's enjoyable anyway, even if you already know everything about soldering. I'm always trying to watch out for you guys and basically goad vendors into giving away free stuff. So I asked Randy, and he agreed to give away one of these Aoye digital soldering stations that they sell. I'll give you details about how to enter the giveaway at the end of the video, and we talk a little bit in the video about why I think this is a kind of a cool product. So Randy, I guess the way we'll start is why don't you tell me who you are and who your company is? Let's do that first.
Okay, sure. My name is Randy Rubenstein. I'm the president of Stan Rubenstein Associates, also known as SRA Soldering Products, and I've been in the soldering industry for about 15 years. My father started the company back in 1962. I took it over about 15 years ago, but I've been doing electronic soldering and so forth probably for 30 to 40 years, so pretty much seen everything in that regard.
And I checked out your website before the interview, and you guys sell all kinds of soldering equipment. You know, you sell like stuff like solder pots and other kinds of equipment that really a hobbyist probably wouldn't use. But you've also got a lot of hobby grade equipment. I was actually looking at your site. Not to go right into the plugs, but I was very interested in one of the digital soldering stations you've got, the Aoye. It's like an $80 soldering station, and I noticed it's got a vibration sensor in the handle, which is actually something I've been wishing I could find. I have a Hako station. It's like a $100 station. It's very nice, but I hate the fact that it stays hot when I set the iron down for 5 minutes, and so I was really impressed.
Right, and then your tips can oxidize when you do that.
Yeah.
So the longer the iron's on, the more oxidation you would get on your soldering tip. So yeah, having a shut-off and cool down is a really good feature.
Yes. So
the other nice feature about that iron is there's 2 preset temperatures, so you can turn it on and it hit your favorite preset temperature, which, say it's 450 degrees. You press that button and the iron automatically heats up without touching any other controls.
Mm-hmm. Yeah.
It's a nice feature.
And you also sell not just soldering equipment, but also, of course, soldering supplies, like, of course, solder. And that was the thing that we first got introduced. Was you guys sent me some solder, both 6040 solder and some 6337 solder. And this is something I've wondered about for a while, like the differences between them and who should be using which. But before we dive into that, let's just start by talking about the solder alloys, and what do we mean when we say 6040 solder? What is that?
Okay, so 6040 is 60% tin, 40% lead, and that's an old alloy that's been around forever. And it's the in the electronics industry, the 6337 has replaced the 6040 solder in electronics. That's actually before lead-free soldering came about. But for the most part, in electronics and hobbyists, people use the 6337. And there's a good reason for that. The 6337 is eutectic. And what that means is that the liquidus and solidus temperature of the solder are the same. And why is that important? That prevents getting cold solder joints. So if you use a 6337, it's virtually impossible to get a cold solder joint. Whereas a 6040 is different in fact that there is a different liquidus and solidus temperature, which means there's a range where it's not quite a liquid, not quite a solid, and if you don't bring it up to the liquidus temperature of that solder, you're not going to get a good solder joint. So that's the main reason why people switch from 6040 to 6337.
And if you guys out there have ever been working on, I noticed this especially on the really big joint. The little joints, they seem like they cool really fast, and even if you're using 6040, they seem to go pretty quickly from the liquid to the solid. But I've seen this especially on the really big joints, like you guys are soldering like a 14 gauge or a 12 gauge wire to an XT60 connector, where you pull the iron away and you're waiting for the solder to kind of, you know how it kind of changes, you can see it go solid, and then it looks like it's kind of gone solid, but then you kind of start to take your hand away and the wire moves and the joint wasn't quite solid yet. And I think, Randy, that's called is that called the plastic phase? There's a liquid, a solid, and a plastic phase. Is that right?
That is called a plastic phase, where it's kind of in between solidus and liquidus. So, for example, the 6040 that is pretty common melts at, it's got a range between 361 and 374. That's Fahrenheit. Whereas the 6337, its liquidus and solidus are 361 Fahrenheit.
Mm-hmm.
So it's slightly lower temperature, and it's virtually impossible to get a cold solder joint with.
And the way people get themselves in trouble, at least one way they get themselves in trouble, is by letting the wire move while the joint is in the plastic phase. If the joint is in the liquid phase and the wire moves, well, it's no big. I mean, it could still create an issue, but the solder is still liquid. It will still sort of solidify around the joint, you know. Whereas if it moves in the plastic phase, it can create voids and cracks in the joints. Or I'm not sure if I'm saying it exactly right. But then,
no, that's correct. You can create a void where you don't have full contact around that wire.
Mm-hmm.
So you may only have 30% of the wire contact in the solder, so you're not going to get as good conductivity through it, and it's going to have a high resistance.
Mm-hmm. So why is it that all the, you know, when you go like into your local Radio Shack, it's all 6040? Why isn't 6337 more common? I mean, obviously you can find it. It's the internet. You can find anything. But why is 6040 still as popular as it is if 6337 is just definitively superior?
A lot of people don't understand the difference between the 6040 and the 6337, for one, especially the people who own hardware stores, since 6040 has been around since the dark ages, and they don't really know solder. Many times people use 6040 for industrial soldering. So let's say you're soldering a part on a lamp, which you really don't care about. It's a non-electrical connection. 6040 will work fine as long as you get the strength that you need.
Mm-hmm.
So that's kind of why it's been around.
Yeah, and it's important to point out, in case nobody's thought of this, that solder is not just used for electrical connections, it's also used for physical connections. You can, similar to brazing or even to welding, obviously they're not the same thing, but if you've ever got, you know, a small piece of metal you want to join, you can solder it. I mean, if you look at my my transmitter strap, the clip on my transmitter strap kept popping open and I was dropping my transmitter. And I otherwise loved the transmitter strap. So I just got out my soldering iron and I soldered the clip closed. And for that kind of soldering, it's less critical if you have like a slightly cold joint because you're not passing electricity through it.
That's correct. So in that case, 6040 is perfect for that. 6040 is a little less expensive typically. Tin is, when you buy a solder, solder with lead in it, the tin is the more expensive component than the lead. So the 6337 is 3% more tin, which makes it a little more expensive.
But I think we could certainly, and I know you've seen this too. There's a whole lot of people out there in the hobbyist market who are doing the best they can to solder, and they're not very good at it. And they need to stack the deck in their favor as much as possible. So if you're really good at soldering, you could probably get a good joint with just the grimiest iron, and you know. But if you're bad at soldering, you need to do everything you can to improve your odds of success. And sounds like using 6337 solder is one thing people can do to accomplish that.
Yep, I definitely agree with that.
Yeah. Is there? Oh, go ahead.
Yeah, I mean,
Go ahead.
when I first started soldering, 6337 wasn't around 40 years ago. I don't know the exact date of when that alloy came about, but the whole industry changed over to that, all the manufacturers, until the change to lead-free happened several years ago.
And I do want to talk about lead-free solder in a minute. I think that's another topic that people are really interested in. But sticking with the 6337, I have two other questions about it. Number one is there a downside to 6337, setting aside the cost? Functionally speaking, does it have any... Are there any applications, we talked about the physical application where you're not passing electricity, but are there any other reasons why someone might choose 6040, obscure applications? I don't know. Or is 6337 just always better, except it's a little more expensive?
Yeah, 6337 is better 100% of the time for electronic applications.
Okay. And then the other question is, if like I don't feel like I have a problem soldering 6040. I get good joints. I don't have any issues. If you're good at soldering, can you just use 6040 and save yourself a little money, or are there still reasons to choose 6337? See what I'm getting at?
Yeah, I mean the cost difference is minimal between the two. So in that case, I would always go with the 6337. Pennies difference, not dollars difference.
Yeah, what's the price difference for like a standard hobbyist size roll, whatever size that would be? What would be the price difference between them?
Yeah, let's say a 4-ounce spool,
Yeah.
maybe 30 cents.
That's nothing.
It's pretty minimal. It's not even worth trying to save the money.
And I solder a lot. Well, I mean, I solder a lot for a hobbyist, I think, not for a pro, and I go through like a 4-ounce spool every 6 months. I don't know. I don't go through a ton of solder. So yeah, so it sounds like everybody should switch to 6337 is the bottom line.
Yes, definitely.
So let's talk about lead-free then. And this is a topic that I get a lot of questions about lead-free solder because everybody is concerned about lead exposure. We have this idea, don't eat lead paint, and we don't want lead in our environment and our gas, and surely we don't want lead in our solder either. And I'm not convinced that there's a huge risk of lead exposure from leaded solder. So my first question is, to the average hobbyist, is there a substantial risk of lead exposure from leaded solder?
So the lead does not vaporize when you're soldering it. So the risk of lead exposure happens to be from touching it with your hands and then putting your hands in your mouth or touching food afterwards. So it happens by ingestion. It's got nothing to do with, so the fumes coming off when you're soldering, that is the flux burning off. That is not lead burning. So those are not lead vapors. So the lead only happens by touching it and introducing that into your mouth somehow.
Yeah, lead vaporizes it like...
Similar to like lead paint.
Right. If you eat, so there's various ways of getting lead into your body, and one way is if you get it hot enough, it will vaporize. It will boil essentially, and you can breathe it, like similar to how people breathe, tobacco smoke and whatever. And that would obviously get a lot of lead into your body very quickly. But lead doesn't vaporize. The number that's coming to my mind is like 4,000 degrees. Well, I don't know if that's right. It's a really high temperature.
That's correct. So in soldering temperatures, there's no way you'll ever get to that point where you're vaporizing the lead. The solder's going to melt. Leaded solder's going to melt at, 360 to 370. So you're not even getting close to the vapor point of the lead.
And then the other way you can get the lead in your body is, well, by handling it. You get lead particles on your skin. If you're the kind of person who's going to stick a piece of solder in your mouth to hold it while you're working with your hands, that's the way you'll get lead exposure from solder.
Right, that's not a good idea. So the best thing to do if working with leaded solder is do your soldering. When you're done, wash your hands, and then do what else you need to do.
Yeah.
But, so just good hygiene, just wash your hands with some soap and water, and that will remove any lead or residues that could be on your hand.
And although I'm not a doctor and neither are you, even if you didn't like wash your hands scrupulously, it really feels like the amount of exposure is still like I used to shoot guns a lot more than I do now. Why I don't shoot is another topic, but I used to shoot a lot, and there was a period of about 6 months when I first got into it when I was at the range 3-4 times a week. And after that 6 months, I went to the doctor and I got a blood test to see if I was getting any exposure, and I had a mildly elevated lead level. I was like, oh, I need to be more careful about this. But I was, guns, lead, I was shooting a lot. It seems like, if you're soldering every day for 8 hours a day, maybe, but if you build a quadcopter once every 2 weeks, even if you don't be scrupulous about your hygiene, there's probably still not a huge risk.
Yep, I agree with that.
So then why are all of the products that we buy, like appliances, and they all use lead-free solder? Why is that?
You can thank California for starting that.
Okay.
They started the lead-free revolution, I guess, and lead is known to cause cancer with high levels of lead exposure and other issues. So the government started requiring people not to put lead in products into landfills and so forth. So a lot of lead was going to the landfills from old circuit boards that were being thrown away.
Right.
So they wanted to reduce that.
It sounds like it's as much about sort of, contamination of whatever groundwater and so forth from the landfills more so than it is. I mean, if there's leaded solder on your circuit board, most people are never even going to be exposed to that. And it was more about the disposal, I think. Is that right?
Exactly. Yep. It's all about the disposal and putting it into landfills.
Yeah. So
because you got a circuit board you're working with, you're really not going to be exposed to the lead. You touch the board, you wash your hands afterwards. It would take a lot of exposure of lead to get it into your system.
And there are substantial downsides to lead-free solder. There are some people who get into this hobby and they buy lead-free solder because they don't know any better, and they're like, "Geez, I'm so bad at soldering." What are some of the downsides of leaded solder, or lead-free solder?
So the downsides are much higher temperature. You're working in, say, 340 degrees or so. So it's a little harder. You need a more powerful soldering iron to do it if you're doing big parts and so forth. Years ago, people had 30-watt soldering irons as kind of the standard, 30 to 40. Now, to really do any lead-free soldering, you need maybe a 60-watt or above iron. So that introduces new costs where you have to buy a better iron. A lot of the cheap irons you get at Radio Shack are maybe only 30 watts. Your $12.99 variety of irons. So that's one thing. So at higher temperatures, you got to get your board up higher, the solder up higher. It just takes a little more time. So most hobbyists still stick with the 6337 for 90% of your applications.
And it doesn't flow as well either, does it?
It does not, because it has no lead, and the lead component of the solder is what helps it flow well.
Yeah. So I would say, I say this, and now I've got a soldering professional who I think agrees with me, that there's no reason, not a health reason, and it's technically inferior to use lead-free solder, that a hobbyist should be using, it sounds like 6337 leaded solder, just bought unquestionably.
Yeah, I would say so. It's going to be so much easier, and you're using such small amounts, it's really not going to affect you or your product, and it's not a high number of drones going in landfills, so
right.
I would have to agree with that. If I do repair on a board, I always use 6337.
And in fact, I've had the experience of trying to do a repair on a board, and it's a commercial board, so it does have lead-free solder. And the first thing I'll do is I'll take a little bit of leaded solder, and I'll just put it on the joint. I'll take a little flux, of course, also, and a little leaded solder and put it on the joint. And if I'm trying to do any kind of rework or remove a part, that really makes it a lot easier.
Right. And what that does, you're alloying the two metals together, which changes the melting point of the overall solder joint by doing that.
So
And that's why it makes it easier.
Let's talk about flux then, because we've mentioned flux a little bit. So what is flux?
Okay, flux is a compound, usually an acid or a rosin-based product, which aids in the soldering process. So what flux does is help you clean the solder joint. So as you start heating with your iron, you notice the flux will spread out and actually cleans the solder joint, so makes it so it can accept the solder much easier than it would without flux. Because what happens, the metal oxidizes, and when you have oxidation, then you can't solder.
Right.
So that's what the flux does.
Oxides prevent heat flow, and they're shockingly effective at preventing heat flow. If you talk about TIG welding of aluminum, one of the reasons TIG welding of aluminum is so hard, well, you have to have specialized equipment because the aluminum forms an oxide on the outer layer, and that's why aluminum is corrosion resistant. But you have to break up that hard oxide layer before you can get the aluminum to melt. A similar thing is happening with copper when we're soldering it, although obviously it's not exactly the same. The oxides aren't as hard. It's a lot easier to get rid of them. But if you've got oxidized metal, or worst case, the tip of your iron is oxidized, you're going to have a terrible time soldering because although it gets hot, it won't transmit the heat into the joint. Is that right?
That's correct. And the solder will not stick to a oxidized joint.
Right. So it'll kind of ball up. It won't spread and flow. It'll act cold, but the issue is that the oxide is preventing it from spreading and flowing and connecting.
Right. So what would happen is if you have you tried soldering without solder, without flux, your solder would just ball up and wouldn't go anywhere. So you'd have just a kind of solder ball sitting on top of your joint, and it never flows into the joint.
And then what the neophyte does is he goes, well, my iron's cold. So he turns the iron up, and it still doesn't work. And he turns the iron up, and it still doesn't work. And then he overheats the joint and damages the board. Like, well,
the other thing you do is you're damaging your tip on the iron by cranking the temperature all the way up. So your tip's going to oxidize. So now you're using a tip that's oxidized onto a board that's oxidized, and you're not getting anywhere.
And the times in my life when I've been soldering and it's not working, and I just want to freaking finish the joint and go fly or whatever. And I get really frustrated, and I find myself just kind of banging my head against it. What's happening? You're not going to fix that problem by like trying harder. I'm making air quotes here. You're not going to fix that problem by what you need to do is figure out what is wrong with your setup. Something's wrong. Your iron is too cold. You have oxidized joint. Something is wrong, and when you fix all the things that are wrong, soldering actually requires very little technique. If you do all the setup and get everything working right, it just sort of it takes care of itself.
Right. The flux works like magic when you put it on a joint. You can try soldering without flux. You put a drop of flux on, and magically the solder melts and flows, and you get a beautiful solder joint.
Yeah. Now, I personally, and this is going to be a controversial statement to a soldering professional, I do not usually use a flux pen or a flux paste. I use rosin-core solder, which for all the people out there, it has a tiny little thread of flux on the inside of the solder or rosin. And I use that and feel like I get good results, and I just can't be bothered to use a flux pen separately for most of my applications. Am I making a huge mistake here, or am I? What's your opinion of that?
Nope, you're not, Joshua. It's using a core solder is much easier than using a solid wire. Now, when you use a core solder, a lot of times you'll go to Home Depot, and they could have a 60-40, but it's got an acid core.
Mm-hmm.
So you need to be very careful not to use anything with an acid core.
Now, is that the plumbing solder? That's not the plumbing solder, is it? That's not the plumbing solder, is it? There's a separate kind of solder for plumbing. I know you're not supposed to use that.
Right. There are plumbing solders. Now, plumbing, they don't use lead anymore.
Uh-huh.
They stopped doing that maybe 30 years ago. But industrial solders you'll find at Home Depot, some of them have an acid core.
Okay.
And we sell a lot of acid core solders. If you're making jewelry, you're going to use an acid core solder. So you got to make sure you're using a solder for electronics, which is either going to be a rosin core or a clean core or no clean core is what they call it.
Now, what's the difference between rosin core and clean core?
So rosin core is a little more active than a clean core. By active I mean it is a little more aggressive of a flux, so it can be used on metals that are slightly oxidized. Whereas a clean core, you're going to have a pretty clean circuit board. You're using circuit boards and components that you buy that are very clean, and they're usually tin plated, which keeps them from oxidizing.
Yeah, and if you, I watched a video, it was by a guy who was like a NASA certified soldering whatever, and it was a how-to video, and the number of steps he put into every single tiny joint was astounding. Like, and the steps included things like using a slightly abrasive pad to remove oxides from the outside, and then using a separate, like it was some kind of solvent alcohol cleanse, I don't know, and that's all involved with removing oxide from the wire. We're obviously not making satellites and spaceships here, but if you've got even a wire that looks reasonably clean probably has a small amount of oxide on it, and that's where I think you're saying that rosin core solder, which is a little more aggressive, can help clean that wire and prevent you from having to do any additional sort of manual cleaning.
That's correct. Yep. So if you're going to do, if you're soldering wires, I would always use a rosin core, just because wires are not tin plated, they will have some oxidation, and the rosin will work better.
Oh, I see. And one of the solders you sent me some solders, a couple different products to try out, and one of them was clean core, and I have been using that. But it sounds like that's more for plate. If I was doing like a surface mount chip to a circuit board, those are all going to have very clean connections and pads. Whereas just a copper wire that I strip the insulation off of, I'd be better off with the rosin core than the clean core.
Yes, I mean, if the clean core works, you can continue to use it. The clean core is going to leave more of a clean-looking solder joint, whereas a rosin is going to leave a brown kind of residue to it. Mm-hmm. Now, if you want to clean up after soldering, both of those residues can be removed by alcohol.
And it is important to remove that residue.
The residue is non-corrosive, so you can leave it there, especially on a clean core. It is meant to be left on the board. But if you're doing, small work, it's so easy to just take a little bit of alcohol on a Q-tip and wipe it on your solder joint, and you can remove any residue. It's
interesting you say that, because I've always heard that the rosin core solder or the flux leaves a corrosive residue that over time will yada, 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 and you're supposed to take a Q-tip with some alcohol on it and clean it off, and I never do, because who's got time for that? And right. I have, maybe it's just because I crash my quadcopter and destroy it before it would cause any damage, I don't know, but I have never noticed any problem from leaving it on there. I've always felt a little bit abashed about it and tried not, because I'm supposed to be like a big shot, but I've never done it. And are you saying that all this time I've been right?
Well, you've been right partially. So there's different types of rosin flux. There's a type R, a type RMA, and a type RA. Okay. So those are kind of to get very technical, those are the three types of rosin. Type R is going to be the most corrosive, and that you should remove. The RMA and the RA, you really don't need to remove.
And is there any way to know which of those is in the solder that I'm buying?
Most of the time it's going to be RMA. That's the most common one out there.
And that is or isn't the kind that you need to remove?
You do not remove it. Okay.
Well, that's very exciting. I always like finding out I've been right all along. Surprising how often that happens. No. So, and then when would you really need to use like a separate flux, like a flux pen or a flux paste, if you're using rosin core solder?
Okay, so let's say you have, you did some soldering, you did it with 6040, and you're not getting good connection, or your circuit board isn't working. So if you want to do rework, Then you would use a little extra flux and just touch the solder joints on your board, put flux on them, touch it with an iron till you get a nice shiny solder joint.
Mm-hmm.
So it's a good troubleshooting tool if you're having an issue on your board and you kind of know the general area it is or the general problem. So you may want to touch up the solder joints on the ICs in that area that are causing the problem. So you can take a flux pen, dab a little flux on, and just hit it with the iron. So they're really used for rework.
And if you guys out there have ever noticed that if you overheat a joint, instead of getting a nice silvery solder, it'll become kind of a dull gray. My understanding is that what's happening there is the flux is sort of cooking out, and eventually it cooks all the way out, and there's no more flux in there, and you get that dull gray kind of sort of oxidized joint. And you can, I believe, you can kind of fix that by adding a little more flux and reheating the joint. Is that right?
That's correct. And the easiest way to do that was with a flux pen. We have 3 different types of flux pens that people use. We have a no-clean flux pen, which gives you a clear finish. We have a rosin, if you think your joints are oxidized, and then we've got a water-soluble, which you can rinse off with just hot water and a little bit of soap.
And a lot of people will be shocked to hear that you're suggesting rinsing an electronic circuit board with water, but actually, as long as it's, it's like distilled water with there's no reason not to do that as long as power is not applied, of course, right?
Right. The most popular flux pens that we sell would be the no clean is number 1, the rosin would be number 2, and the water soluble is distant 3rd place. So it's really the no clean and the rosin that people use for rework. And that way you don't have to worry about rinsing with water or cleaning it. And that will give you your shiny joint. So if you got a joint that's not so shiny and could be causing problems, just put a little flux on it, hit it with the iron. As soon as the flux is molten, take your iron away, and it should harden with a nice shinier finish than what you had.
Cool. So let's now I want to talk about temperature for soldering. And you said solder melts at 360 something degrees Fahrenheit. But most of our soldering irons, I mean, if I think about my Hakko, it came from them with the default at I think it was like 700 or maybe 750 degrees. And sometimes people say to me, "Oh, it's solder melts at you don't need to solder any higher than such and such because you just need to be right at the melting point." What's the temperature that you suggest for sort of general purpose soldering? First of all,
you don't want to be at the melting point because your iron may not be accurate enough, or the control circuit, and your solder may never melt. So you don't want to be at the melting temperature. On the other side of the equation, you don't want to be at 600 to 700 because that's going to oxidize your tips very quickly, and you'll be replacing your soldering iron tips. So you want to be somewhere in between, and it's a function of soldering time, how long it's going to take you to do the joint, how many watts your iron is. But as a rule of thumb, I usually start at like 450.
450 Fahrenheit?
My iron. Fahrenheit, 450 degrees Fahrenheit.
Wow, I'm really surprised to hear that. The like I just go with what my the Hakko I've got came with the presets from the factory, and the presets were between I think 650 and 850 were the presets. So I'm surprised that you're down that low.
Yeah, they want to sell you more tips. That's why it's set so high.
That's really interesting. I'll have to try that.
If you're using a lead-free solder, you're going to be closer to the 550 to 600 degrees range. So that's the other disadvantage of lead-free. You need a higher temperature to melt it.
I've heard the argument made, and I confess to making this argument myself, that with a higher temperature, you heat the joint more quickly, you get more localized heat, and less sort of heat spread out through the component. Is there any merit to that argument?
Yeah, there is some merit to that, but it's a trade-off between oxidizing your tips and doing that. Now, if you're doing purely work on a soldering on a circuit board, you can use a lower temperature. If you're going to do, for example, you're soldering some wires, say they're stranded wires and they're thicker, you're going to need to set your iron to a higher temperature.
Now let's talk about that, because I think there's a relationship here between the temperature you set the iron at, the wattage of the iron, and the size of the joint you're working on that is not necessarily obvious to a lot of people. So do you see what I'm getting at there? You want to try and sort of broach that?
Right. So if you're soldering a wire, so let's say you're at 450 or 400, what's going to happen? Your copper transmits the heat.
Mm-hmm.
So you're going to be heating at, say, 450, but the copper is dissipating the heat almost as quickly as you're trying to heat it.
Right.
That's where a higher wattage iron comes in. And if you don't have the high wattage, you probably want to use a higher temperature
Mm-hmm.
because it's going to dissipate slower than a lower temperature would be.
So if you,
So that's kind of the trade-off.
If you've got a high wattage iron, that's the simple way to think about that is how fast the iron can pump heat into the tip. And so if you've got a high wattage iron, you may be able to work with a lower temperature, because as the component sucks the heat out of the iron can just pump the heat right back in. But if you've got a low wattage iron,
Recovery time on the iron. So if you have a low wattage iron and you're putting it against a cold piece of wire, the temperature of the tip is going to drop.
mm-hmm.
If you have a low wattage iron, it's going to take a longer time to heat up.
Mm-hmm.
So it's exactly what you explained.
and you can compensate for that to some degree by using a higher temperature. If you're at a higher temperature, then you'll be able to get enough heat into the joint to complete the joint before the tip cools enough that the iron can't keep up with it anymore.
That's correct, Joshua. Yep.
Okay. Good. I think that's a really good. Some people who are using a very low temperature on their iron and getting good results, I wonder if they've got like a 60 or an 80 watt iron, and that's why they're able to do it. Whereas the guys who are like, "What are you talking about? I can't be that low," they may have a 35 watt iron. And the other thing that I think we got to touch on is temperature controlled versus non-temperature controlled irons. Is there those irons that don't have a temperature control? It's just like a 60 watt heating iron. What do you think of those? Is there a place for those?
Not really. The cost of temperature-controlled irons has dropped dramatically over the last 3 to 4 years. You can really get a nice 60-watt controllable iron for about $30.
And what's the difference between a temperature controlled and a non-temperature controlled iron?
The non-temperature controlled irons are set to whatever they heat up to, and they could be 600 degrees, so the tips are going to oxidize. You really have no control over your soldering process because the tips are going to oxidize. You may be getting your joint too hot, you're burning up the flux. It's just too many variables, and it's not, you got an expensive copter you're working on. Why use a cheap tool?
Yeah. Does the non-temperature controlled iron have a temperature sensor in it? I always thought that they were just essentially like a heating element on a hot plate. They just push. I mean, it's been designed to kind of hit a certain temperature, but who knows? You're just pushing current through it, right?
There is no sensor in there, and there's no feedback to the control system.
Whereas
So you can get your $13 iron from Radio Shack, which is non-temperature controlled. If you're doing one solder joint, you want to solder some speaker wires, that's fine. But if you're doing work on an expensive board, the drones are not cheap to buy and build, so you might as well have a better tool
mm-hmm.
to build it. Something you're going to invest in. You don't need a $80 iron. You can get away with a $30 iron that would have same properties as a more expensive one.
Yeah. That temperature control is also nice because you can have, if you had an 85 watt, for example, iron that was not temperature controlled, it would run at 900 degrees and overheat and be terrible. But if you've got a temperature controlled iron, then it'll only hit it with that 85 watts when it cools down and quickly bring it back up to temperature and then wait. So you can have an iron that is both really powerful but also maintains a precise temperature.
Correct. Yeah. So all the temperature-controlled irons have a sensor in the iron and a feedback loop to the microprocessor in the base, and it's going to continually monitor the temperature, pump more current into the heating element as the temperature drops, and also helps it recover quicker with a high wattage iron.
Good. Yeah. Good, awesome. I want to talk a little bit about some of the other products that you sent me. I think we've done this is a really great sort of intro to a lot of topics that are central to just the act of soldering. But you sent me some other stuff. One of the things you sent me was what is it? It's called Fast Chip. Is that the correct name for it?
Yes. So the fast chip is an interesting product. The fast chip contains parts. There's a flux that goes with it. It's a no clean tacky flux, and then there's the removal alloy. And what the removal alloy is, it's a very low temperature alloy, and it's used for help you to remove solder that's on a IC, for example. Let's say you've got a surface mount IC, and you try removing it with an iron. You'd have to use like a solder sucker and a solder wick and try to remove the solder off each pad, and you could have 80 pads, which is probably an all-day project trying to do that.
Yeah.
So if you're trying to remove it with just an iron, you can't get the iron on all four sides of the chip to remove it.
Right. And just to make this relevant to the folks who are watching, an example of when you guys might do this is if you're trying to remove the capacitor from a BLHeli ESC so that you can run D-Shot 600 on it. And you can't get both sides of the capacitor. Sorry about that. Hold on. You can't get both sides of the capacitor hot at the same time. So you got to try to use a physical means like cutting it off or filing it off, and you potentially damage your board. Go ahead, Randy.
That's correct. So with the fast chip alloy, what that does is you're mixing that alloy with the solder alloy you have on your board. And what that does, when you mix the two alloys, you get back into a very wide range of the liquidus and solidus temperatures. So this new alloy you've created by putting your solder, the fast chip, onto the 6337, you've created a new alloy which has a range of, say, even 150 degrees, where it's in that state of flux, where it's not liquid, it's not solid. So what you're able to do is you put that on all four sides of your IC, and then once you have it on all four sides, you take your iron, you get into that liquid stage on one side, you keep on moving around the chip. By the time you get to the fourth side, it's still in the liquid state because it hasn't cooled off yet to become a solid.
Mm-hmm.
And at that point, once all four sides are liquid, you can just slide the chip right off the board without damaging it.
Mm-hmm. It's similar to having a hot air station, isn't it? In that you can apply that. Yeah.
It would be almost the same function as having a hot air station, but you're doing it with a $13 kit of wire and flux.
And in some sense,
So if you're not removing a lot of them, that's the way to go.
And in some sense, I think it's a little better than a hot air station. I know one of the things beginners do, especially with a hot air station, is they overheat things. They heat things that are not trying to remove, and then suddenly stuff is just sliding all over the place. With this, you put the alloy on, and you physically touch it with the tip of the iron, and you know the heat is only going exactly on the chip that you're trying to remove.
Correct. It's similar to what you said you do with the lead-free, when you have a lead-free chip and you put some leaded solder on it to make it easier to remove. So it's kind of that same process and the same chemistry that's happening.
Good. Well, we're starting to come towards the end of our time. I do want to ask a couple. I really appreciate you being here, and I know one of the reasons you're here is because you want everybody to know about your company and how great it is. So one of the sort of softball questions I want to throw you is, what's the difference between like a good quality solder, like presumably SRA makes, and like a cheap solder that you just get from, whoever knows where? Because I presume you guys feel like you make a better quality product. Yeah?
Right. So, yes, we do. And the main reason is we use virgin material. So we're buying virgin tin, virgin lead, which has never been used before. So what happens in China, with some of the solders you get from China, there's going to be impurities in the solder. They're not going to use virgin materials. So there's going to be impurities which could affect your solder joint, the conductivity of the solder once it's on wire or so forth, and it'll affect the melting temperature. It's just not as consistent as using virgin materials would be.
Mm-hmm. Good. And
so the Chinese solders are known to be bad in the industry. Not to knock the Chinese, but they're cheap.
Well, and I'm sure a lot of that is reclaimed metals, recycled, reclaimed metals with potentially other components in it, other metals, other alloys that maybe aren't necessarily supposed to be there.
That's correct.
Are there any other? Go ahead.
That's the main difference of cheap solders versus good solders.
Are there any other products that, I glanced at your website and I was impressed. I'm always looking for new products that are good quality, have good feature set, and that are still affordable for folks who can't, necessarily spend $100 on a solder station. And oftentimes that means, you're buying something from China. So it was nice to see these. I don't know, where are the IUA solder stations manufactured?
They are actually made in China.
Nothing against that.
They have very good quality control. They've been manufacturing these for about 15 years now. We've been selling them for about 12 years. So we introduced them into the U.S. about 12 years ago. And quality is very good. Price is very competitive. And they're good, reliable stations.
And I know that especially here in the U.S., everybody's big on American manufacturing, and that's a political topic that we're not going to really broach. But I do think one of the best ways to balance the desire to provide an economical product with the desire to provide a quality product is to have like an American dealer who handles the manufacturing and the quality control and the customer support. But still, the stuff is still manufactured in China because that's how you save money. Just because you got a Chinese product doesn't mean if you bought solder station 101 off of Alibaba, who knows what you're getting. But a product like this, it seems like a really good way to get a balance between quality and price. Are there any other?
It's important to buy from a manufacturer that is selling the brand and knows about it, knows how to service it. If you go onto eBay, you'll find much cheaper irons. You'll buy from some random seller. And then when you go to buy parts for it, or it breaks, or the tips don't fit, you're out of luck.
Yep.
So the important is to buy from a reputable dealer in the U.S. that is not just an eBay seller.
Yep.
Because those stations, we get so many calls for people who have a hot air station that they bought on eBay. They paid $30 for a hot air station, which is very inexpensive, and you kind of get what you pay for in that regard. And there's no one to support it. They can't buy accessories for it, and that eBay seller is either gone or doesn't know how to support it.
And when the price point,
to buy a soldering iron from someone who's going to be able to support it, and it has the spare parts, tips that go with it, spare irons, spare heating elements, because the heating element will break on an iron, and it just happens, and just from repeated heating and cooling cycles, the element will break.
Yeah.
So you want to get an iron that has a element that can be replaced, and you have a source to buy that.
When the price point between an iron that has support, has aftermarket support, has parts, can be repaired and so forth, and an iron that it doesn't, is the difference between $30 and $60. That's not really a big ask. You only have to replace that cheap iron one time before you've broke even on the one that you could keep using for a long time.
Exactly. Now, our lowest price product we have is the RU 469 soldering iron, which is actually a soldering station. It is temperature controlled. It's got a dial, so you don't need the exact temperature. You have a reference temperature, but that is 100% better than $15 Radio Shack iron if it's still in business.
Yeah. How much is that one?
It does have temperature control.
And how much is that one?
$30, $29.99.
Give me a break. Yeah. So good. Well, I was happy to learn about that. And are there any other interesting products that you think my viewers might like to know about?
Well, you mentioned our 9378, which is our $80 iron. What's interesting about that is they just came up with a new heating element that's a plug-in heating element. Every other iron in the market, you have to desolder the element to replace it, which makes it difficult. If your soldering iron's broken, so you got to go borrow a friend's iron.
Oh, right. You got the bootstrap problem. You need a soldering iron to fix your soldering iron.
Right. So the 9378 now has a plug-in element
Mm-hmm.
that can easily be changed. And also the 9378 is going to have a whole bunch of new accessories coming out for it, which will plug into that same base iron, and each accessory you plug in has a different calibration, and the iron base knows about it, and it can modify the calibration. So the 9378 is also, you can do a calibration. Let's say you're using a big wide tip, a big heavy tip, and you set it to 470, but you read the temperature, it's only reading like 450.
Mm-hmm.
You can do a 20-degree offset internally to get it to match the tip that's on there.
Nice.
That's if you're really getting into sophisticated soldering. But
Nice.
the biggest feature I see right now in the 9378 is the pluggable element.
That's exciting. I wouldn't have thought of that. Cool. Well, I think that is going to do it. I think we've gone on more than long enough. Yeah, thank you, Randy, for being here. Anything you want to say to close out?
Nope. Thank you for your time, Joshua, and
Absolutely.
look forward to seeing it on your blog.
Well, I hope you guys enjoyed watching that interview as much as I enjoyed doing it. It was really a pleasure to talk to Randy about soldering. Now let's talk about the giveaway. The giveaway product is a 9378 digital soldering station. I'll put a link to it down in the video description so you can go check it out. In order to enter the giveaway, you need to leave one comment below. Leave only one comment. If you leave more than one comment, your entry will be disqualified. You can't have multiple entries, obviously. I will be moderating the comments to this video in order to keep myself from being just overwhelmed with notifications. So if you leave a comment and you don't see it appear immediately, don't freak out, and definitely don't leave a second comment or you'll be disqualified. I'll approve them manually. Don't worry about that. The way my giveaways usually work is that shipping is the responsibility of the winner, and that's just the only fair way I can think of to handle the case where sometimes people live really far away and it's expensive to mail them things, and it's just up to you whether you want to pay shipping for the product. In this case, SRA will pay shipping if you're within the United States. If you're outside of the United States, it's too expensive, and it's up to you whether you want to pay to get it delivered to wherever you are. Oh, and by the way, don't worry about the fact that the product listing says it's a 110-volt soldering station. SRA has confirmed to me that it also comes in a 220-volt version, so no matter where you are, you're eligible to enter and to win. So good. The full terms and conditions are in the video description, and the stuff in the video description, if it disagrees with anything I just said, the stuff in the video description is the right thing. I'm going to do the drawing, let's say 3 days from now, so within about roughly 72 hours from now, I'll do the drawing. I'll post another video with the winner in it. That's all. Thanks for watching. Happy flying.